Hello. So today I will talk about connected mobility, which is the domain which deals mostly with connecting vehicles, users, devices, and of course the services behind them all. And I will start and talk to you about the challenges in integrating the EV charging communication protocols. Okay. All right. So, what is a charging station? Many of you know, many don't. It's a little box meant to charge your vehicle in the same way a charger charges your phone, or a fuel pump charges your internal combustion car. Now, the EV basically is driven by an electrical motor, so it has a battery which needs to be charged from time to time. These boxes, these charging stations, are operated by CPO, charge point operators, which stand for either a person who is installing the device or managing it from distance, or it's basically the system. The backend system is also named charge point operator. These charging stations can be connected to a backend, and the backend is responsible for monitoring them, for remote control, and basically for their entire management. An e-mobility provider is another player in the ecosystem. Basically owns the user contracts. You as a user, you have a mobile phone application or an in-car dashboard where you can find, let's say, the nearest charging station or an available charging station when you run out of energy. These applications that are provided to users, they can be in form of mobile application or let's say even tablets. And they are responsible for anything related to end users, including payment, usage, authentication, and so on. An e-roaming platform stands between the CPO and the EMP, and its role is to allow, for instance, a CPO to offer its infrastructure to multiple electromobility providers, and an EMP can offer its users and their data to multiple CPOs. On the right side, you see several players, big companies that are active in this field today. A typical ecosystem it's considered like this. So basically, you have the user with the car, you have the charging station where you interact physically with it. You have either the mobile phone application or the in-dash application which connects to the EMP. You have the charge point management system, which is the CPO in our diagram, and you have the e-roaming platform in between. Now, as far as the protocols go, typically the application talks with the EMP via REST APIs. And we have two protocols which are in scope. One is OCPP, which is the protocol between the charging station and its backend, and the OICP, which stands between the backend and the roaming platform, but also between the roaming platform and the e-mobility provider. It will be explained later. Now, these two standards, they are open. One was created by Open Charge Alliance, and the second by Hubject, which is a private company, and they released the protocol as open source earlier this year. Okay, OCPP, the first protocol between the charge point and the central system. Now, this is how they name the players. It's the charging station and the central system, they play both client and server roles by turns. Both parties can initiate operations. For instance, a charging station can send its status or notify the backend when it starts, or other kind of monitoring operations. And the central system, it usually sends remote commands like remote start, reboot, stuff like this. The OICP is in the middle, so it's the EMP and it's the charge point operator. exactly the same way, the operations can be initiated by the other party. The EMP can command a charge point operator to start a transaction, basically to open a socket on the charging station, and the CPO backend will forward the command to the actual charging station. And the other way around, when a charging station sends a notification, it will be forwarded to the roaming platform and eventually to the mobility provider and the user application, so that in real time you will see when a charging station is available, is charging, or in other state. Okay, now in integrating the charging stations, we have a few challenges. The first and the biggest one is supporting the multiple protocol versions in the same time. Manufacturers, they made the charging stations, let's say, during years, different years, and they slowly start to adopt the protocols. They even have some proprietary protocols. And in order to solve the problem, basically the CPO backend needs its own domain, where it contains the business logic and everything. And we have a sort of gateway which transforms from the request from the charging station into the business logic, into the domain request, and vice versa from the domain request to the charging station request, specific to each protocol. The second challenge is integration of non-compliant charging stations. Now, not all charging stations are fully compliant with the protocol due to budget, due to, I don't know, the year it was released, due to hardware limitation and so on. And in order to support everything correctly, we can either make an attempt of trial and error approaches, and of course we'll get a lot of errors because we don't know beforehand if the station is going to restart or not. Or we can take a more different approach when we group the station by templates, and we know that a particular model is not able to restart until it finishes all transactions, or another model, it starts immediately. This is one typical case. Okay, another topic is, or another challenge is security. The hardware of the charging station is pretty limited, so not all of them can implement security. Some of them, they have WS security for SOAP version of the OCPP protocol, but not all of them. HTTPS is also mostly not supported. And we risk our backend to be exposed to man-in-the-middle, replay attacks, and others. To contain this, we implement an authentication mechanism for a charging station with security tokens, which are generated by the backend system, and also contain the charging station in the VPNs or APNs, so the access is limited to the backend. Another challenge is the testing. With lots of models and manufacturers, you cannot test everything, so you have to limit to one or two during the development, but then what do you do with the others? So our idea was to implement a simulator where we can simulate pretty much any behavior. We get an earlier feedback, so we can explore the corner cases, and we can also customize each simulator instance for a specific model. It can help with automated tests, and yeah, they don't consume much. And the last challenge is multi-tenancy. Imagine that you have several tenants wanting to expose or to control a specific set of charging stations with a single system. You have to think of this starting with the application design, data isolation, and it could affect the performance. And of course, you have to think of scalability and security, because the thing is, from one tenant, you cannot give access to some charging stations which it should not have. And the last part is the master-slave setup, where not all charging stations will be connected directly to a backend. So they will be connected to another charging station and another and another and so on. And at the end of the grid, one of them will communicate with the backend, which will lead to some operations not available. If you want to restart a specific station from the grid, the slave stations, you will not be able to do that unless you restart the entire grid. That's how it works. So basically, this is it about the challenges.